So now that I've talked a bit about operations for converting things like collections into streams, the so-called creational operations, let's talk about aggregate operations. Those are the other operations you can have in a stream. And we're going to talk about the structure and functionality of stream aggregate operations, which will include, as we'll see, intermediate and terminal operations. So what is an aggregate operation? It's a higher order function that applies a behavior on the elements in a stream. That's not particularly enlightening unless you know what a higher order function is. And a higher order function is just a fancy schmancy term for a function that's passed a function as a parameter. So what we're doing here, of course, is we have these aggregate operations, things like map and flatMap and collect and so on, and we're passing them behaviors. And so you'll see that the behaviors that are passed can be lambda expressions or method references to various things like functions, predicates, consumers, suppliers. You can also have objects that are these things as well. So that's the higher order function, the behaviors that are passed to these aggregate operations. What's the win? We've talked about this before, but just to quickly recap it, these aggregate operations form a pipeline of declarative operations that emphasize the what, in other words, what are we trying to do, and de-emphasize the how. Not that how is not important, not that implementation details don't matter, but it's not what we use to structure the program at the sort of the top level of the decomposition. There are two types of aggregate operations. The first type are intermediate operations, which process the elements in an input stream and yield an output stream. You've seen a bunch of examples. You're using a bunch of examples. You've used a bunch of these examples, things like filter, map, flatMap, which are ones we've talked about, and you'll get a chance to play more with in the next assignment. There's also other more advanced ones came later in Java 9, like take while, drop while, et cetera, et cetera. And it turns out that there's a way to classify these intermediate operations by several dimensions. So you can classify them by whether they are stateful or stateless. And stateful just means, do they store information that's needed for next to be able to carry out the behaviors as the program is running in the stream. So for example, there's stateful operations like distinct, skipped, sorted, limit, take while, drop while. These things need to take into account the state of what's occurred in order to be able to do their thing. A simple example would be sorted. You're not going to be able to sort a stream until you've got all the elements in the stream. So you've got to have a stateful behavior there. So it keeps track of the history of the invocations. And then there's also stateless operations that are intermediate operations, and they don't store information from any prior invocations. They're lightweight, light as a feather. So this is really the bulk of the operations like filter, map, flatMap, and so on and so forth. So those are stateful and stateless are two dimensions that are important. Remember, wherever possible, you should try to use stateless operations if you can, because they use less memory, they use less processing, and they also work better when you start dealing with parallel computing because they don't keep state you have to deal with. Now, you can't always do that. If you want to sort something, you're going to need to use sorted. That's stateful. But if you can get away with using the stateless operations, you're better. The other dimension is run to completion versus short circuiting. So run to completion means that unless something drastically horrible goes wrong that requires an exception to be thrown, every element in the input stream will be processed by that operation. So things like sorted, filter, map, flatMap, they look at all the elements in the stream, and they go to the end, again, unless you throw an exception, which is rare. The other way of slicing and dicing this is to talk about short-circuiting or short-circuit operations. And these are ones where the stream doesn't, in fact, process all the data. So some good examples here would be things like limit. If you put a limit, then let's say you have 1 million items in your stream, but you only want to take the first 5, then in that case, it's going to short circuit. After it gets to the 5th element, it stops doing any more processing. And we'll see that other methods like other operations like take while and drop while are also short circuiting. Once the predicate that they're passing in is not met, then they stop doing their thing. So short circuiting, run to completion, one dimension, stateful, stateless, another dimension. And it helps to kind of keep that in mind. There are no stateless short circuiting operations for intermediate operations. The other kind of operations are the so-called terminal operations. And these are the operations that trigger the intermediate operations, because remember, everything's lazy till the terminal operation is hit. And they also produce a non-stream result. So these would be things like forEach, reduced, collect, find any, and so on and so forth. Remember that a stream can only have one terminal operation. And if you want the stream to run, you have to have one. Now, as you will see when we do programming assignment number 3B, which is coming out here in the not-too-distant future, and actually I think 3A does this too, you can have streams that don't have terminal operations immediately, but they need to have a terminal operation ultimately if you want them to run. And so you'll get a chance to see that with assignment 3. It's kind of cool. So terminal operations can also be classified into run to completion versus short circuiting. So things like reduce, collect, forEach, they will terminate only after every element in the stream is processed. But there are other ones like all match, any match, find first, find any, none match, and so on, that may terminate before all the values are processed based on predicates that are passed or behaviors. So typically you'll pass in a predicate and then it'll terminate. For example, if you pass in all match, then the moment something doesn't match the predicate, the terminal operation bails out because it failed its predicate. So those are the ways of slicing and dicing the terminal operations and the intermediate operations. So let's talk about a little interesting piece of trivia related to these aggregate operation interactions. It turns out that intermediate operations are in fact optional in a Java stream. So you can have code that looks like this. You can say, create for me a stream of the names of the characters in Hamlet, and then no intermediate operations whatsoever. We go from a creation factory method operation to a terminal operation, boom. And so we could say, give me a count of these values. So there's no intermediate operations at all. However, this is very subtle and can be a little confusing. The semantics of the count terminal operations, at least for my money, are somewhat counterintuitive. And as of Java 9, if you have something like this, where you have the creation of a stream followed by some intermediate operation that doesn't have any side effects, followed by the count operation, the system will actually omit this call altogether. And you can read about sort of the fact that that's the case. I'm not sure why they decided to do that. I think it's very confusing. So you just have to be aware of that you can short circuit yourself to the point where certain operations don't get printed at all. Now, in this case, if you replace peek with map, map can have side effects, so then it won't omit it. But peek will just be elided. That's the fancy word. If you really want to get peek to run, then you need to appear to access some things somehow, like by putting in a filter. But this is kind of a hack. Okay, so that's a quick overview of stream aggregate operations. The two different kinds that are most important are intermediate and terminal.